Since I don't have a slide about myself, I'll do that while we wait for the formal. So I'm Eduardo Pelegri. I work at Progress. I've been there for about a year. Before that, I was at BlackBerry for about 3 years, I think. And then I spent most of my career at Sun Microsystems. And what I do at Progress is a bit of a strategy, a bit of corporate development, and then I've been doing some on IoT, and I'll give you that background. So, I mean, if you want to talk with me afterwards, we'd love to chat. I'll tell you a bit about Progress in just a second. If you have been around, I wrote the JSP spec, and I did a lot of Java stuff some time ago. Since there was a big break before that, I might as well get it started. You guys okay? Okay, so what I'm going to tell you is a bit about how we are using Node. And the context here is, I'll tell you who we are and why we care about IoT and how Node is helping us with that, right? So this is that's the perspective on this presentation. So I have 2 examples at the end, and I have 1 demo that I can give you within that context. So Progress is a company that has been around for quite a while. The first release was back in '84. Every now and then I bump into somebody that says, yeah, I remember Progress. It started as a development environment and a deployment environment for relational databases. So it has its own multi-tenant database. It has nice things like encryption, transparent encryption. It was very, very popular in the '80s. It created a whole generation of ERP, CRM applications based on that. One of the nice things it had this language that if you look at it today, it looks like COBOL, that in 4 lines you can create a simple UI that lets you manipulate a database. And that became extremely popular. And the same way that Visual Basic apps started growing, we have millions of lines of code in apps that do backend for everything, right? From managing your Subway fast food to point of sales to the hospitality backends for Hilton, et cetera, et cetera. So there is a very large install base out there. The language itself has mutated, and it's actually modern today. It has object-oriented and all of that stuff. The challenge that we have is how to bring all those applications to the modern world, right? So what we have been doing over the last few years is we acquire Rollbase, which is akin to Force.com. Is very close to the in functionality to Force.com. So you can define objects with different fields that come from different places. It has a very good way to import external objects. This is relevant. We'll talk about that at the end of the presentation in the demo. And then very quickly you can create a very simple UI, which is exactly what enterprises want, right? So this is not, Rollbase is not your, what they call nowadays system of engagement, is not for creating high volume like a Flickr app. On the other hand, we have a Rollbase Mobile, which is an Apache Cordova-based platform, and that is a bit closer to that. But essentially, what's happening is that we are moving towards we recognize that IoT for us is going to be very soon where mobile is today, right? So every application is going to need that, and I'll tell you about that. We'll also have a few other things. The most important thing relevant here is that we acquired at the beginning of the summer a company called Modulus, which has a very flexible, very competent Node.js, MongoDB set of tools that allows both in the cloud, virtual private cloud, and on-premise managing. It has the notion of servers. It's very scalable, et cetera, et cetera. So with that as a background, what we are looking at is, okay, IoT is here. Really, it's not like it's coming. It really is here for a bunch of applications. And even our traditional customers, which are our partners and end users, which are looking at things that are kind of very back-end-ish, they also need these systems of engagement, right? So we have a bunch of applications that are happening on the IoT space. Many of these are actually relevant to our customers. So for example, we have a company called, DMSI. What they do is backends for warehouses, right? So they would like to know where their delivery vehicles are. They want to know where the inventory is. And this is happening very, very quickly because we have this acceleration from the consumer space to the enterprise space to the retail space. So everything is happening very quickly. So these guys want to write these applications. We have another company called GMT. They do waste management. They track things like your recycling containers being full, when do you have to go and send a truck to empty a waste container. They are based in Europe, and the dynamics in Europe are a bit different here, and so there is more demand on that, especially in the Netherlands, which is where they are located. We have a company called Macintosh. They are kind of a traditional retail company. They are also based in the UK, the Netherlands, and Belgium, I believe, and they want to enhance the experience of their customers so that they can compete with people like Zappos, right? I mean, it's a very tough market out there. Then we have a small company called Jungle Lasers that I'll show you a demo about, and that's they do applications for municipalities, right? So this is, depending on what your definition is, but this is smart cities, right? So they are doing very simple apps, but they want to know things like where the snow plows are, and that's the demo I'll show you. Okay. So our customers are moving in this direction, and the question for us is, how can they build these apps? So what do we have to need to add to our platform for them to be able to do these things? Right. Not tracking the time here, especially since I didn't started. All right. So the tool that we're using for this is Node, right? So what we have been doing is looking at how we can leverage Node with our existing infrastructure, with our existing products, do small changes to our product line, but leverage Node as the gluing machinery for all of this, right? So you all know about Node. From our perspective, when we acquired the company, we were focused on, okay, JavaScript is having a huge growth. Node is having a huge growth. This is why we bought Modulus. From the perspective of IoT, it's a very good match for event-based, highly scalable, web API focus. It's a great integration point for anything that's coming in and out. It's extremely efficient, and there is a huge community, right? So I think last week we passed 100,000 modules on NPM, right? So anything that you want to support, it's there. Maybe the package is not very good, but one of the 10 packages that says that they support MQTT is probably doing the right thing. So you have to know which one it is, but they are there, right? So that's our angle. So what we did over the last few months is we started creating some sample apps that show how this would fit in our space. Right. So if you go to github.com/progress, you're going to see, I think that we have like 10 of them, and they do different things. Some of them are more IoT, some of them are more Node. But the first one that we did is just playing a bit with iBeacon, and I suspect that all of you know about this, but just briefly. So the iBeacon is based on Bluetooth Low Energy. It beeps on a regular basis. Each device, the devices range from very small devices to medium-sized, and I expect that this is going to continue happening. I'm surprised that we haven't seen a combo Philips Hue with an iBeacon in there. But the two that you see there are from Gimbal, and what they provide is a UID, and then the signal strength gives you an idea about how the proximity you have to the beacon, right? So on the iOS side, you get essentially an event that gets delivered to your application that has been registered on your iOS device, even if it's not running, is going to get delivered the event with an indication about whether the beacon is very close by. I think it's near, medium, and far, or you have lost the range, right? The cost of these things on units of one, I don't know what the volume cost is. For the top one is $5. For the medium one is, I believe it's $20 or 10, I forgot. The top one has one of those button batteries, so they last, in theory, 6 months. Our experience has been less than that, but I think that depends a lot on the software. I'm assuming that all of this is being fine-tuned. And then the one in the middle has 4 AA batteries, I think, and that's supposed to last 2 years. The range of the middle one is bigger. The big one is about 50 meters. So I assume that most of you know about these technologies. Does that make sense? All right. And then the Philips Hue, that's a more interesting. You probably I don't know where you know about this one, but the device itself, the LEDs are talking Zigbee, which is a mesh-based low-power protocol, and then the bridge itself is actually is the one that talks the IP stack. This particular bridge, I believe it has a Tomcat underneath. If it doesn't, it feels like Tomcat, but you can talk through it through an Ethernet, and then you can control all the devices by using HTTP requests into the bridge. The bridge itself also pings through, and if if it can reach the internet, you can also go through a web connection. But and sometimes it's a bit more complicated to decide under what conditions you can do it. So we have only used it as a way to talk directly through the bridge. So the bridge has to be reachable from wherever you're controlling the lights. And then the bridge is going to send a request using Zigbee that will hop from one bulb to another bulb to tell the bulb what to do. Right? A bridge can connect up to 50 LEDs. And so by doing the mesh, you can cover a fairly good amount of space. And the prices of these are coming down. I believe that today's price, it depends on whether you're using an LED that has multi-hues or not. The single hue 2 LED with a bridge at Apple Store is costing $99. And this should come down. And I fully expect that at some point there's going to be a combo of this that has inside, in addition to the light, is going to have an iBeacon, but I haven't seen it. So we use this as an example of a combination of devices, activators, and sensors that would make sense for somebody to interact with, right? So it was a proof of concept, but the way we did it is we wanted to detect as people come into a space, the office or whatever it is, and then we want to use the lights to indicate that that person is present or not, right? So this is work that was done with 2 summer interns of mine. They were between freshman and sophomore year. Very smart and capable, but they cranked all the samples. One was 13 weeks with me, and the other one was 6 weeks with us. So it's a good reflection, actually, of the power of Node, because they did one sample after another, right? So it was very productive. So the way we did this is the architecture that we put together. And again, this is a proof of concept. I'll do just a bit of a commenting here. But the basic architecture is fairly simple. We just have a listener on the iOS device that detects the iBeacons coming in and out. And we chose to use the foundation classes. And when we were doing this thing with iOS 7.1 as opposed to 8, and it just sends to the node layer. In the node layer, we record all the activity into MongoDB. And then you can also consult the node layer to find out what's happening, right? So we're using Express for providing a status through a web page. And then so this is fairly standard. It scales very nicely. We could, at the node layer, from our perspective, at the node layer, we could either consume directly from Gimbal geolocation services, right? So Gimbal provides a geolocation service. We do not necessarily have to use and implement this ourselves. We could be consuming it from somewhere else. At that layer, we could go and ping some other services. As I mentioned briefly at the beginning, one of our services is a Corticon service, is a decision service. In principle, we could even use some rules to make decisions at that layer. We haven't really tried on performance. I don't know where that would scale or not for our needs. But again, most of our customers don't have the web scale problems that you would encounter if you were doing it, I mean, for Flickr or something like that, right? So this is all from the perspective of our customer base. So that's the way you would track the activity. Very, very simple here. Now, on the other side, to control the smart lights, this is a bit for kicks kind of thing. We wrote a Node application to actually control it. The only tricky part here is that because the smart lights are behind the firewall, then the question is, check here. Oop. Is how do you control those guys? Because you cannot address the bridge directly because you are on private IP addresses, right? So what we did is poking through the firewall to go to the node layer and then just find out whether something needs to be done, right? So there are different ways of doing this thing, but that was the structure. So from our perspective, when I show this thing to my customers, they get it. They start to say, oh, okay, I see how I could do something like this for whatever is my retail store, et cetera. So this is more of a kind of getting people on board. And again, it's pointing out this is the kind of things that you can do at the node layer. Now, a more interesting example is the snowplow, architecturally speaking. So this is done by the Jungle Lasers guys. Jungle Lasers does municipality apps. What they wanted, they have a number of cities that they work with. And the cities want to know what streets have been cleaned or salted. So this is a real example. In one of the cities, they have a hospital that performs dialysis for the patients. So they want to notify the patients when they can actually go from their home to the hospital to perform dialysis, right? So they want to know that type of thing. So it's a very good example for us because it shows how you need to write an application that interacts with the IoT space. In this case, it's just a GPS feed, but it's a connected device. And then we want to interact with the rest of the space, which are the municipality data that can be things that includes fallen trees, branches, power lines that fell, the hospital data, citizen information, et cetera, right? So the way this was done initially is they used this role-based machinery. Think about Salesforce, Force.com kind of thing. But there was an individual that was actually looking and operating the whole process. Then they automated it using PHP and MySQL database, but that couldn't integrate with the rest. So what we ended up doing is this structure, which I believe it's a good architecture in general, at least at our scale. So what we have is we have Rollbase, which natively understands a protocol that's called JSDO. It's our own protocol, but it's not that different than in many other protocols. It's a REST-based protocol and JSON-based protocol, where the Rollbase uses a request to get a catalog of objects, external objects to Rollbase. Again, think about Force.com. And then it can request the objects. It can mutate the objects locally, and then it can push the object modified back to the external source. And we have that protocol. We have used it for a number of things internally. So what we did in this example is we implemented the server side of a protocol, which normally lives on OpenEdge, in Node, right? So the full story here goes, Modulus, which is our Node platform, is actually used for about 4 different things. So the request is coming from the GPS feed. Node is processing those requests. They don't come very often. It's like every few seconds you can actually go and pull, and that's enough because the truck doesn't move that fast and they're not, right? So you just get all the truck data. And then we store all the data in MongoDB, right? So MongoDB is our historical data for all the information that is happening on all of these trucks, right? And now we have a different Node service that exposes the most recent location of those trucks into Rollbase. So from the Rollbase, you can create a combined object that has this, and it has one of the data is the GPS location. And now we use all our standard machinery to consume that information. So we can use REST protocols to go into Rollbase and get the object information, because we have a get that gives you the object. And this is a synthetic object that some of the data is coming from the municipality data and some of it is coming from the Mongo layer, right? And we have the Rollbase Mobile, which is the Apache Cordova that does the same thing. And then the Angular the single page application that I can show you in just a second is actually either going directly to the Rollbase or is going to the Node layer and getting the historical data. So this architecture for us works very well, and it's a good way of gluing things. At the Node layer, we can do anything we want now, right? Because it's a very good web API based infrastructure. You can use it to do whatever you want. You can consult information, et cetera. So that's the main architecture that we put together for this. Let me see whether I can show you the demo here very quickly. It's not super demo. So this is actually the single page app. It's an AngularJS, pretty standard AngularJS app. Is using the Google app to get the, let me reload it. So you see that, and hopefully it's not going to break. I never do those things. Look. Okay, hopefully I shouldn't have done that. There it goes. Do we have a very slow connection? Hey. So the red dots are actually, everything is coming from Rollbase, right, from the synthetic object definition. The red markers are actually coming from the snowplows. And if you click on one of the markers, then there's an HTTP request that goes to the Rollbase. It says, okay, this is my zip code. Give me all the users that correspond to that zip code. Then it comes back. Right? So it's pretty much what you would expect. If you wanted to go to one of these users, if I click on this, then I can send a message. In this demo, it's not done, but we have a backend service that does push notifications. So you could go to this guy and then do a push notification into your mobile device. At this point, you understand how it works. I mean, we have collected everything into our standard infrastructure, and then if you go from here, you can do the create a new user that, again, does an HTTP request to the Rollbase application. If you go to historical, then you can ask, and this feed doesn't have a lot of data, so I have to actually go relatively far down in time. But if I go this and the demo gods actually work, then this is going to do a direct call to the MongoDB, and it gets me the most recent data from Mongo. Right. So that's the basic architecture that we think it's going to work fairly well for us, and that's the way we're progressing on this. So from our perspective, IoT is here to stay. We need to address these things. A relatively simple solution like this one with, I mean, we're leveraging on all the Node infrastructure, right? I mean, which is a big thing. But it gives us a lot of functionality. And once we're in Node, we can do anything, right? So from Node, we can call into the decision service, we can call into the backend, we can call into Rollbase. We have a demo that shows a very simple block system that uses Node the same way that you would use parse, right? Just as the object database at the back. And that's the thank you to my summer interns. So I think that I'm past my time. Can I do a couple of questions if anybody has questions, or do I have to vacate? So I can do a couple of questions if anybody has questions.
Yes, the next presenter here. No, go ahead.
No questions? Yes, sir. Hey, hi.
You mentioned how you monetize it. Is it like a whole platform? Is it
Oh, how we monetize? Well, so we sell. So these are our products. I don't know whether you were here when we were talking about this thing. Hello, back. We sell the platform as for development and deployment. So it's very similar to the way Salesforce sells monetizes Force. Sorry, I didn't realize it was this slow. There it is. So we sell on-premise, non-on-premise, per user, not per user. The IoT side is just part of cost of doing business. We sell Modulus separate, and actually Modulus is very cheap if you are just running on the cloud for a small volume. One of the challenges with making money from Node is that it's so efficient that you don't have to charge much for it. But yeah. Yeah, we don't have our own IoT platform. It's kind of, it's like Salesforce, right? So if you go to Salesforce, you'll see a bunch of samples about how to use wearables with Salesforce. We haven't focused on wearables because architecturally it's not complicated, right? But we should add some wearables samples. We have focused on the harder things that we didn't know exactly how to do it. Any other questions? Thank you very much. Appreciate it.